Okay, here we are with our new unit, Unit 4, and our first lesson, which we will be talking about percent. So on your lesson worksheet, go ahead and take a look at opening exercise 1, match the percents with the correct sentence clues, and then continue the video to check your work. Alright, so you should have finished matching and it should look like this. If you have any questions about the matching, again, make a note on your lesson worksheet and bring it to class. Alright, for opening exercise 2, which is on your lesson worksheet, go ahead and color in the grids to represent the following fractions. Continue the video to check your work. Alright, you should be done coloring in the grids on your lesson worksheet for opening exercise 2. And you should have something that looks similar to this. Notice that 30 over 100, since there's 100 parts in this grid, is the same, or would represent 30 over 100. 3 100ths would represent 3 units, and 1/3 of 100 would mean about shading in approximately 1/3 of 1 square. So now let's start our discussion, and you're going to take notes in your math journal. So how are these fractions and representations related to percents? Again, make your best guess and then continue the video. Well, percent means out of 100 and can be written as a fraction with a denominator of 100. So what are equivalent representations of 30 over 100? So what other ways can we write 30 out of 100? Well, some things you might have come up with is 3 out of 10 or 15 out of 30, or we can write it as 30% because it's per cent or per 100, or 3/10, which is the same representation as 3 over 10. So what do these have in common? Well, they are all equal to 30%. The first two are equivalent fractions simplified by a common factor. The 30% is in percent form, and the last is in decimal form. So notice the shaded areas. They are equivalent in each square, but the partitions are different. So if you measure the area here, it is the same as the area here, and the same as the area here. This has to do with common factors and common multiples. Notice that 30 out of 100, since this is 100 squares and 30 of them are shaded, can be the same as if we take this and split it into 10 equal sections and color in 3, or if we split this into 50 parts and color in 15. So having equal partitions and equivalent copies are equivalent fractions or ratios. So why are these all equal to 30%? Well, because the numerator-denominator is a part-to-whole relationship. Remember our extensive discussion on ratios. And 3 out of 10 is 30%. The decimal, 3/10, represents 3/10, which is also equivalent to 30%. So what are the other equivalent representations of 1/3 over 100? So think about that. How else can we represent 1/3 out of 100? Well, that would be 1/3%, or it could be 0.3 repeating percent, or it could be 3/10 repeating, or 0.3 repeating, and also it could also mean 1 out of 300. So let's take a look at example 1 on your lesson worksheet. Use the definition of the word percent to write each percent as a fraction and then as a decimal. Continue the video to check your work. Alright, so you should have written, if we are writing this as a fraction, remember percent means per 100. So that tells you right there that everything is going to be written over the denominator of 100. So even though this is a decimal over a whole number, this is still considered a fraction. So really, 37.5% is 37.5 over 100. Then 100% would be 100 over 100, and so on and so forth. Notice that 1/2% is a complex fraction, 1/2 over 100. So now if we write that as a decimal, we just move the decimal. If we're dividing by 100, we are moving the decimal point 2 powers of 10, so that's why this would be 375 over 1,000th. Or if we wanted to make this a whole number, we would multiply this by 10 to make it 375, and 100 times 10 to make it 1,000, and that also gives us our decimal representation of 375 thousandths. 100 over 100 would obviously be 1. 110 over 100 would be 1 and 10 hundredths. And 1/100th would be 0.01. And 1/2 over 100, again if we simplify this, would give us 5 thousandths. So we would multiply this by 10 to give us 5, and we would multiply this by 10 to give us 1,000, and that's how we get 5 thousandths. Alright, back to our math journal. So what is the pattern or process that you recall or notice when converting percents to fractions? Well, we place the percent value over 100 and we simplify it if we can. So if I gave you a number as a fraction, how could you tell me what percent the fraction represents? Well, you would find the equivalent fraction with the denominator of 100. Here's an example. To convert a fraction like 7 over 20 to a percent, I would want the denominator of 20 to be partitioned so that I have 100. Well, to go from 20 to 100, I would multiply by 5, or partition each section 5 more times. Well, when I cut those partitions, don't forget that it affects the copies too. So that would mean 7 times 5 means that now I have 35 copies of 100 partitions. So this would be 35% if we wanted to convert it to a percent. So what mathematical process is occurring for the percent to convert to a decimal? Well, the percent is being divided by 100. So if I gave you a number as a decimal, how could you tell me what percent the decimal represents? Well, we would multiply by 100. So here is example 2 on the lesson worksheet. Fill in the chart by converting between fractions, decimals, and percents. Show your work in the space below on the chart on the worksheet. Then continue the video to check your work. Alright, you should have finished the chart, and this is what you should have. Well, 7/2 would be the same as 3 5/10, and that as a percent would be 350%. Or working backwards, I would write this over 100 and then simplify it to 3.5 over 1, which is the same as 7 over 2. If we're given 25 thousandths as a decimal, then I would write that as 25 over 1,000. If I wanted to write a fraction, here's one way. You don't have to have 2.5 over 100, but you would have an equivalent fraction. But also knowing that in order to have this fraction so we could write it as a percent, it would be 2.5% or 2.5%. If we're given 1/8, then I would need to make my 8 into a power of 10. Well, 8 can't go into 100, but 8 definitely goes into 1,000. So we would have 125 times 125 here, and you would get 125 over 1,000. Well, that is also 12.5% if we want to back it down to a denominator of 100 to write a percent. So we would get 12.5% or 12.5%. If any of this does not make sense, make sure you make a note of it and bring it to class so we can discuss it further. All right, so going back to showing how each one of these are made, 350% as a fraction would be 350 over 100, which simplifies to 35 over 10, or 7/2. 350% as a decimal would be 350 over 100, and then knowing that the shortcut for 350 over 100 is 3.50. And to write it as a visual, it would be 3 wholes plus half of another whole. Another one, 25 thousandths as a fraction. If we wanted to write this as 100, it would be 2.5 over 100, or 2.5 over 100. And 0.025 or 25 thousandths as a percent, being that this would be out of 100, it would be 2.5 of one of the squares. So it'd be 2.5%. 1/8 as a percent, again moving from 8 to 1,000, then changing it back to 100 would be 12.5. So that would be 12.5%. Or as a decimal, again they kind of skipped over making this to 1,000, or you can just take this and multiply it by 10 to make it 1,000, and that's where we get the decimal 125 thousandths. The visual representation for percent would be 12 squares plus half of another square. All right, let's wrap this up. So what does percent mean? Well, it means per 100, or for each 100. Is the value of 7/10 less than or greater than the value of 7/10 of a percent? Why? Well, the value of 7/10 is greater than 7/10% because a percent means that it's over 100, which makes 7/10% equivalent to 7/10 over 100. And that would be less than 7 over 10. How are the fraction and decimal representations related to percent? Well, they are related to whatever p is, whatever the percent is, over 100. And what do percents greater than 1 look like, and why? Well, they are percents greater than 100%, which would be improper fractions, or decimals greater than 1. All right, we'll see you in class.